You know that feeling, right? When you're wrestling with a tough problem, just completely stuck, and then bam, the solution just hits you. That Eureka moment. Well, today we're tackling a really cool question. Can an AI have a moment like that? We're going to look at a new model, DeepSeek R1, and this incredible new method that might just be teaching AI how to have its very own aha moments.
Okay, so let's get right into it. Picture this. Researchers are training this new AI, and they noticed something unexpected. The AI started showing a behavior that didn't look like it was just following code. No, it looked a lot more like a mind having a genuine flash of insight.
And that really brings us to the heart of the mystery for today's explainer. Is it actually possible for an algorithm for just lines of code to replicate that spark, that sudden leap of understanding that we always thought was uniquely human?
What's so wild is that you can actually break this down into clear stages. See, the AI isn't just guessing an answer. It goes through a whole process. It tries something, then it recognizes, wait, that's not quite right. Then it corrects itself. And here's the kicker. It then explains why the new way is better. That suggests something much deeper than just memorization is going on here.
It's really just like when you're doing a puzzle. You try to force a piece in and you get that feeling of, nope, that doesn't fit. Then you have that little aha, and you see exactly where it's supposed to go. This model is showing that same kind of logical, step-by-step reasoning, all by itself.
So this is all pretty mind-blowing, but where did it even come from? This wasn't just some random model off the shelf. Let's meet the AI at the center of all this, DeepSeek R1.
And really, we're talking about two flavors of the same model. On one side, you've got DeepSeek R1.0. Think of this as the raw, pure experiment. They trained it with only reinforcement learning, and crazily enough, these reasoning skills just appeared. They emerged. Then on the other side, you've got the polished final version, DeepSeek R1, which takes that raw ability and fine-tunes it to be even smarter and easier to understand.
And this chart really tells the whole story. Just look at the performance on Amy. That's a super difficult math competition. The pure R1.0 model already gets a crazy impressive 71%. But then, with that extra layer of fine-tuning, the final R1 model jumps up to almost 80%. It shows how they captured that lightning in a bottle, that emergent reasoning, and then refined it into something seriously powerful.
All right, now for the part you've been waiting for. How in the world did they pull this off? How do you actually teach an AI to think like this? Well, the secret sauce is a brand new training method called GRPO. That stands for Group Relative Policy Optimization.
Now, this quote from the research paper sounds super technical, but the key phrase is preference rectification. All that really means is that they found a much more direct way to teach the AI what a good answer looks like compared to a bad one. It's not just about being right or wrong, it's about understanding the subtle qualities of a better solution.
The beauty of GRPO is its simplicity. It's really just this elegant three-step dance. First, it has the AI come up with a bunch of different answers to the same problem. Then, it looks at that whole group of answers and figures out which one is the best of the bunch. And finally, it updates itself to be more like that winning answer.
So think of that first step like this. You're a student facing a really hard math problem. Instead of just trying one approach and giving up, you might scribble a few different methods in the margins of your notebook. That's what the AI is doing here. It's exploring all the different pathways before picking one.
And step 2? This is where it gets really smart. It's basically grading on a curve. It's not asking, is this answer a 9 out of 10? Instead, it's asking, out of all the attempts we just made, which one is the strongest? That relative comparison is way more efficient. And finally, the optimization step. This is where the learning actually sticks. The model reinforces those winning strategies so it'll use them again. But, and this is super important, there's a safety net built in. It's a concept called KL divergence, and it basically tells the model, hey, learn this new thing, but don't change so radically that you forget everything else you're good at. It keeps the whole learning process stable.
Okay, so the method is clever, it's elegant, but does it actually work? Does it produce a better AI? Let's get to the results because they are seriously impressive.
This number right here is a statement, a nearly 80% score on the American Invitational Mathematics Examination. We're talking about a test that stumps some of the brightest high school students in the country, and DeepSeek R1 just set a new state-of-the-art. This is a massive leap forward for AI math skills.
And get this, it's not a one-trick pony, not by a long shot. Look at these scores across the board. An incredible 97% on another math test, a massive 65.9% on a live coding benchmark, over 90% on general knowledge.
This new training method has unlocked top-tier performance everywhere.
But here's the kicker. This might be the most important number on the screen. All of that brain power comes at a ridiculously low cost. We're talking just 14 cents per million input tokens. That means this isn't just some fancy lab experiment. This is a powerful tool that's practical and accessible enough for the real world.
Okay, so we've been deep in the weeds on how this all works. Let's zoom out now and ask the big question. Why does any of this matter? What are the real-world implications of this breakthrough?
First, let's be real. The researchers are very upfront that this isn't a magic wand. There are trade-offs. Creating lots of different solutions takes more computing power, and getting all the settings dialed in just right is a delicate balancing act. Like any big engineering leap, it comes with its own set of challenges.
But here's the bottom line, the real game changer here. This research proves that you can get an AI to develop incredibly strong reasoning skills just through trial and error, through pure reinforcement learning. It challenges this long-held idea that you need to spoon-feed an AI massive amounts of human-labeled data to make it smart. This opens up a whole new, much more efficient way to build powerful AI.
And that's the ultimate impact, isn't it? By cracking the code on how to get this amazing performance at a low cost, this work is helping to democratize AI. It's bridging the gap between what's possible in a billion-dollar research lab and what's practical for developers, students, and businesses everywhere.
Which leaves us with one final, huge question to think about. We've just seen an AI learn to reason at a level that rivals the best human minds in super complex fields like math and coding. If this new, super efficient way of learning keeps getting better, what problems that we think are unsolvable today are going to be next? The AI's aha moment might just be the beginning of our own.